Working of planetary gear set.
Hi everybody, welcome back to my YouTube channel Core Classroom Learning. Today we're going to talk about a very important and a very interesting concept called as planetary gear set. So we also discussed this concept, or rather I mentioned about this concept in our last video. Let's now have a look in detail. How does the planetary gear set work? So this planetary gear set is also called an epicyclic gear set. Okay. So a planetary gear set has four main parts: sun gear, planet gear, ring gear, and a carrier. Okay. So if you see, we have the sun gear at the center. We have the planet gears, which you see are rotating right now, attached to the blue, yellow, and green lines, which is nothing but your carrier. And then you also have the ring gear, which is basically your outer layer, right? Now, any one of them can be input, output, or fixed. So there are different cases and different scenarios. This is how you can visualize in an easy format how a planetary gear set basically looks like. Okay. This is a image of a planetary gear set, again, where you see you have the sun gear at the which will usually be at the middle. You have the planet gears, which could be 3 or 4 in numbers, and then you have the ring gears. And each of these gears have teeth. So I'm going to zoom in. Okay. So if you see, when two gears are moving, they should basically have the same interface, right? For example, if this is moving and this is A and this is B, they should have the same interface. That is, VA is equal to V of B at meeting point. Okay. It is also important to know that the sun gear will be the one which will be at the center. The planet gears are these ones, and the planet gears are the ones which will revolve basically around the sun gears. Okay, now we can have different scenarios where your ring gear could be stationary or your sun gear could be stationary. So based on that, the torque is increased or decreased, and you can get a difference in speeds. And similarly, we'll also see a case of how reverse gear works in case of a planetary gear set. So now let's move to case 1. Okay, so case 1 is that your ring gear is stationary and we are going to rotate the planet gear. That means this will be stationary, right? And we will rotate the planet gears. What does that mean? So basically, let's consider this a point A, and I'm going to consider this a point B. Now, since one is stationary and one will be moving, so at A and B, there will be different velocities. That means there will be different velocities at the top and bottom. So it will spin and turn at the same time. When I say turn, turn means the direction changes. Spin means the nature at which it is rotating. That means it would be faster or slower. So the gears will spin and turn at the same time. So the turning will be at a unidirectional velocity. So what happens in that case? Now your spinning is going to be something, when I say spin, it's going to be something like this, and like this will be your turn, right? So that means the velocity over VB, and then here we can get VA. Okay. So in that case, the velocity at VB will be 0, and at VA it will get added, right? Why VB will be 0? Because your ring gear is stationary. So at this point, this is stationary, but only this is moving, right? So it will be 0. But at VA, A has some speed already. So it will get added. So basically, your spinning will produce velocity at opposite direction, and turning will produce your unidirectional velocity, which means that when I say we will spin, it would be like something like this. Okay, but when I say turn, turning means in like this, because B is 0, and then you will have a velocity at point A. Since your carrier is also attached to planet gear, it will turn the planet gear. So that is how it will end up moving at a certain speed. This is case number 1. Now let's see another case, which is case number 2. Okay, so moving on to case 2 where we have the sun gear as stationary and ring gear as rotating. It will be nearly opposite to what we discussed in case 1, right? Because now this is going to be stationary and this is going to be rotating your ring gear. So that means the planetary gear will spin reverse in order to satisfy the speed conditions. So basically all the planet gears, they will spin and turn at a higher speed, right? So the velocity at VB will be high. So you'll get a high speed and it will be higher because now we have the ring gear which is rotating, and it's also due to the radius of the ring gear is more. So now your carrier can turn at a higher speed. Now we can also discuss all the three cases in a slightly different way. For example, if we consider certain number of teeth for your ring gear, sun gear or planet gear. For example, your ring gear has around, I don't know, 100 teeth, sun gear has around 50 teeth, and then let's say your planet gear has around 25 teeth. Okay, and then we have these three scenarios. Let's discuss case number 1 where your sun gear is input, ring gear is fixed. Okay, so your ring gear is fixed, sun gear is going to be the output, and then the carrier, which is basically what's going to be driving all of them, okay, at the back side, that will be your output. So in such case, what would happen? Your output speed would be less than the input speed. That means the torque, you'll get more torque. Okay, so this is basically ideal for we need higher torque, right? Similarly, if we have ring gear as input, right, so this will be your input, this becomes your input, sun gear is fixed and your carrier is your output. In that case, what would happen? We can get different speed, and we can get different torque combination, because now your sun gear is fixed, right? So that means you're having ring gear as input and then your carrier as outputs. So basically here we get different speed torque combinations and your output speed would be less, but there would be less reduction as compared to case 1. So less reduction. Okay, and since this there will be less speed reduction, so you will have more torque. So direction of your planet carrier and the direction of your ring gear will be same in case number 2. In case number, coming to case number 3, we have ring gear as input, we have planet gear is fixed, and now your sun gear will be your output, which means speed would increase because this is fixed but this is the input. So your speed will increase. That means so your sun gear speed will be greater than ring gear, okay, but direction will be opposite, so there will be lesser torque in this case. So basically these scenarios basically explain that how one system can have multiple gear ratios by changing your input and output. So how a reverse mechanism of planet gear works. So basically for reverse gear you need to arrest the motion of your carrier. Okay. So when would you call it reverse gear? If the direction of rotation of your ring gear is opposite to that of sun gear, which means if this is rotating in this direction and this is rotating in this direction, it would become a reverse gear. So to get different speed inputs, different parts of planetary gear sets, we need to move. So to get different speed inputs, you need different parts of planetary gear set, right? Which is ideally very difficult to achieve. So in a planetary gear system, that is why we have 3 sets connected in series, like you see in the image, with a coaxial shafts and they work together. Okay, but the concept remains the same and each of them works in that way. So I hope the concept of planetary gear set is clear now. And if you have any questions, please feel free to drop by. I'll also try to post a video of how a conventional differential works and how does the automatic transmission work, as in the difference between them. Till then, stay tuned. Don't forget to like, share, and subscribe. Thank you so much. Have a great day.